Welcome to the second in the series on measuring the performance of the economy. The first part was on the gross domestic product, its definition. In this session, we will be converting nominal GDP to real GDP. As you know, the gross domestic product is the broadest measure of economic performance that we have. And it is defined as the market value of all final goods and services produced within the boundaries of the US in 1 year. Now, in our last session, we saw the importance of using the market value of goods and services when computing the GDP. First of all, the market value provides us with an objective measure of the value of the good or service. The only person's opinion is the person who purchased it. That's the only one that counts. Not your opinion, not my opinion, not anybody else's opinion. And so in that sense, it is an objective measure of the value of a good or service. But secondly, and most important in this context, is that the market value of a good or service provides us with a common denominator so that we are not burdened by the apples and oranges problem. Now you recall, hopefully from the first session, that the apples and oranges problem derived from the fact that apples and oranges are not additive. And because they are not additive, product prices are essential in computing GDP because they both have product prices and we can add those prices. Thus, the prices are the common denominator that makes them additive. But product prices often change from year to year due to inflation. And that's going to produce a problem that we need to deal with. Now, usually prices from year to year go up, but sometimes they actually fall, and that is known as deflation. So what effect would a changing product price have on the GDP? Let's consider a very simple example. In year one, some economy produced 10 widgets and sold them for $5 each. Now, this is a one good economy, okay? Keep the math simple. They produced 10 widgets and sold them for $5 each. Obviously, the GDP would be 50. Now, in year two, this economy produced 10 widgets, same amount, as you can see, and sold them for $6 a piece. What would the GDP be then? The GDP would be 60. Now, even though there was no change in output, the circular flow didn't go around any faster or any slower, it goes around at the same rate, the GDP rose by 20%. Now, let's look at the way in which I computed this percentage change. You're going to need to know this very, very well for test number 3. The percentage change is computed by this formula: the new value minus the old value divided by the old value. Now, this is going to give us a fraction, and so to change that into a percentage, we multiply that by 100. So you might want to pause this video, write this down so that it gets firmly implanted in your head. You'll have an opportunity to practice these later, but make sure that you understand this formula for computing percentage change. You'll need this formula for the rest of your life, whether you major in economics, finance, business, or don't major in anything. You're still going to need to know how to compute percentage changes. And here's the way you do it. So get good at it real quick. So in this case, the new value was 60. The old value was 50. Old value 50. New value minus old value divided by old value. So that's 10 over 50 multiplied by 100. So 10 times 100 is 1,000 divided by 50 is 20. Now, to show that we multiplied it by 100 there, we put a little percentage sign there, okay? In other words, this is 10 over 50, that's 1/5 times 100. 1/5 is the fraction. 0.2 would be the fraction. Multiply that by 100, that's 20. And to show that we multiplied it by 100, we put that little percentage sign behind it. So as you can see, there are two variables now that affect the GDP. One is prices of the products, and the other is the quantity of output. But it is the output that we want the GDP to reflect in order to measure the productivity of the economy. It's the amount of output that the economy produces that is important. That shows how fast that circular flow is going around. We need prices for reasons I've already stated, but what is important is quantity. So we've got to figure out how to hold price constant. By having these two variables, we're turning two dials at once. Now, that's not going to give us any information. We want to hold this dial constant and just turn this dial right here. See what happens. So we want to hold price constant. And so now we're going to distinguish between the concept of nominal and real GDP. Now, nominal GDP, sometimes called current dollar GDP, because it considers the value of the dollar as it is currently, the current value of the dollar. The nominal or current dollar GDP considers the market value of output at its current dollar value and does not correct for changes in prices, whether it's inflation or deflation. Now, as you are going to see, that does not give us an accurate picture of what is happening in the economy, because the value of its unit of measure, the dollar, varies from year to year. When the price level rises, the value of the dollar falls. And that I'm talking about the purchasing power value of the dollar. And when the price level falls, the purchasing power value, the real value of the dollar, rises. So the term nominal means in money terms. Thus, the nominal GDP measures the GDP strictly in terms of money, with no adjustments whatsoever. The real GDP, sometimes called the constant dollar GDP, because it holds prices and thus the value of the dollar constant. As a result, the real or constant dollar GDP more accurately tracks the change in output because it uses a unit of measure that has the same value from year to year. Because it uses a unit of measure that has a constant value, it effectively corrects for inflation or deflation, which would change the value of the dollar. So let's get into an exercise where we will be converting nominal GDP to real GDP. So we'll start by considering an economy that produces only one good. We'll call it widgets, doesn't matter what we call it. Now, this one good, that's going to save us a lot of unnecessary math, and I'll explain why in just a moment. So what we'll do, we will track the changes in this economy's GDP over a 6-year period of time and compare nominal GDP to real GDP and see which one more accurately reflects what's happening in the economy. So here's that 6-year period of time, year 1, year 2, year 3, etc. Now, let's suppose that in this one good economy, widgets, here is the output from year to year. In year 1, they produce 2 widgets. In year 3, the economy produces 3 widgets. In year 3, 6 widgets, etc. Now, let's compute, before we do anything else, let's compute the percentage change in output. because ultimately what we're going to want is we want the GDP to show us what is happening to output. So we will want the percentage change in GDP to be the very same as the percentage change in output. So let's compute the percentage change in output. Now, the percentage change in output from year 1 to year 2 is the new value, 3, minus the old value, 2, divided by the old value, 2. Now, here's that 3 minus 2 divided by 2. And we multiply that by 100. And this, of course, 3 minus 2 is 1. So that's 1/2 multiplied by 100. That's 50%. Now, before we go any farther, let me just make a note on computing percentage changes. Take a look at this grid here. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sections of this grid. And we will number each one, 1, 2, 3, all the way to 10 in each case. Now, let's look at the percentage change from 1 to 2. You'll note that it is 100%. Anytime anything doubles, it's a 100% change. 2 divided by 1, new divided by old, new minus old is 1. 1 divided by 1 is 1. Multiply that by 110. 100. Sorry about that. Now, let's see you compute the percentage change from 2 to 3. You might want to pause the video. Compute the percentage change from 2 to 3. Okay, pause the video and do that. Use the new value minus the old value divided by the old value, and then multiply that fraction by 100. See what you come up with. Pause it now. Okay, so you're back. Did you get 50%? 3 minus 2 is 1, divided by 2 is 1/2, multiplied by 100 is 50. Now do the same thing for 3 to 4. Pause the tape now and compute the percentage change from 3 to 4. Okay, so you're back. Did you get 33.3%? Okay. From 4 to 5 would be a 25% change. You can check that out if you'd like. Now, what I would suggest that you do is to compute the rest of these. You might want to jot this little grid down here on the back of an envelope someplace and compute these percentage changes. Okay. The change from 5 to 6 you'll find is 20% change. From 6 to 7, 16.666. 7 to 8, 14.3. You'll find that. Just check it out and do it. And that'll give you sufficient practice that you will need for computing these percentage changes on test number 3. But now watch this. The percentage change from 5 to 4 is not negative 25%, even though you're moving from the same distance between the same two increments. A movement from 4 to 5 is 1/4. A movement from 5 to 4 is 1/5. 20%. Check this out. Pause the video and make sure a negative 20%. What is the percentage change from 4 to 3? Again, check it out. Pause the video and see if you can figure that one out. It's a 25% change. Now, from 3 to 4 is a 33% change. From 4 to 3 is a negative 25% change. From 3 to 2 is a negative 33% change. And from 2 to 1 is a negative 50% change. Now, you'll notice how quirky percentage changes are, because not only does percentage change differ from increment to increment based upon where we are in the grid, but it also changes based upon the direction in which we are going. From 1 to 2 is 100, from 2 to 3 is 50, from 3 to 4 is 33.3, from 4 to 5 is 25, from 5 to 6 is 20. From 5 to 4, negative 20, 4 to 3, negative 25, 3 to 2, negative 33, from 2 to 150. Now, make sure that you can compute all of these things and you understand the computation of these intuitively. That's going to help you out a lot, not only for this class, but that's going to help you for the rest of your life. I can promise you. Taking 10 minutes to fill out this grid is going to have a return on that 10-minute investment that is much higher than virtually any other investment you can make. Okay, this is going to be very productive and yield high returns if you fill out this grid on your own. So the percent change in output from year 1, 2 to 3 is 50%. The year change from 2 to 3 in output, from 2 to 3, it would be 3 units to 6 units. That, notice it's doubled, so it's a 100% change. And you can go ahead and fill out the rest of those. You may want to, again, pause the video to make sure that you can check those out and compute them. Now, in our third column here, let's put price. We'll put the price at which these products are sold, at which widgets are sold. In year 1, a widget sold for $2. In year 2, a widget sold for $2. In year 3, a widget sold for $4, etc. Now that we have the price at which these products are sold, we can compute the nominal or current dollar GDP. Now, the nominal or current dollar GDP is simply the units of output multiplied by their price. In this case, 2 times 2 is 4. In this case, 3 times 2, 6. 6 times 4 is 24, etc. Now, let's compute the percentage change in nominal GDP and see how well it reflects what is happening in the economy. Here, the percentage change in output shows us what's happening in the economy. And remember, this is a one good economy, so we don't really need prices here. But in a multi-good economy, we do. So here's the nominal or current dollar GDP. Let's compute the percentage change. Now, from 4 to 6, that would be 6 minus 4, which is 2, divided by 4. 2 over 4 is 1/2, multiplied by 100, 50%. From 6 to 4, check that out. Pause the video here, see if you can see what that is. From 6 to 24. Okay, you're back now. Did you get a 300% change? Now check these out too. See if you can compute these as well. All right, now, don't just look at them, actually compute them. Do yourself a favor. Now, what you will notice is that here, from year 1 to year 2, the percent change in nominal GDP actually matches the percent change in output. But from year 2 to year 3, the percent change in output was 100%, but the nominal GDP is 300%, changes by 300%. From year 3 to year 4, the output changes by 50%, but the nominal GDP increases by 125%. What's up with that? You can see that these percentage changes in nominal GDP are not matching the percentage change in output, except, of course, for the first one. And maybe you can see why the first one actually matches. It's because the price did not change. So the price was held constant. So now what we want to do, we see the problem with nominal GDP. It's not a good reflection of what's happening in the economy at all, because we're turning two dials, price and quantity. So let's begin the process of converting nominal to real GDP. In this next column here, therefore, we want to compute what is called the price index. Now, an index is a number that has no meaning whatsoever when standing on its own. It only has meaning when compared to something else. And the price index is going to show us the degree by which prices have risen since some specified period of time. And we'll call that specified period of time the base or reference year. So let's arbitrarily designate year one as the base year. So how would we compute the price index? Well, the price index shows us the degree by which prices have changed since this base or reference year, and it shows us it is computed by the price level in the current year divided by the price level in the base year. This shows us the degree by which prices have changed since the base year, the price level in the current year divided by the price level in the base year. Now, in reality, the Bureau of Labor Statistics, which is a part of the Department of Labor, averages thousands of prices of goods and services together to get the price level for a specific year. Now, the price level is just an average of a market basket of goods and services that are consumed. In reality, there are all kinds of price indices. There's the producer price index, the wholesale price index, the agricultural price index, the manufacturing price index, and the list goes on. The one that we know best and have heard of most frequently is the consumer price index. In fact, the consumer price index is the one that's used for measuring inflation, which we will see shortly, not in this video, but the next one. The consumer price index consists of a market basket of goods and services that are consumed by the typical consumer. We use the consumer price index because not all of us are wholesalers, not all of us are manufacturers, not all of us are farmers, but all of us, 100% of us, are consumers. And so the Bureau of Labor Statistics sends its workers out into the fields and goes shopping. And in the process, they don't actually buy anything, but they price things. And they take all of this information about prices, they bring them back to the office, throw them into the hopper, and average them up. Now, it's not a straight line average, it's a weighted average. And the reason it's a weighted average is so that the change in the price of a house won't overwhelm a change in the price of a gallon of milk, or the change in the price of a car won't overwhelm a change in the price of, let's say, a watermelon. So they compute the average, weighted average of a market basket of prices that the typical consumer purchases. And this weighted average then is called the price level, as PL, price level. And the price index, oh, by the way, since we only have one product, the price level in our example here is going to be the price of the product. We don't have a lot of averaging to do. That's the math I was talking about where it's going to save us. So the price level in the current year is 2. The price level in the base year is 2. And so the price index obviously is 1. Price level in current year divided by the price level in the base year. Now, let's compute the price index for year 2. Price level in the current year, 2, divided by the price level in the base year, 2. 1. Price index is 1. Now, let's look at the price index for year 3. The price level in the current year, year 3, which is 4, divided by the price level in the base year is year 1, which is 2. 4 divided by 2 is 2. So the price index for year 3 is 2. Now, just make sure that you understand how the rest of these numbers were computed, 3, 2, 2.5. You may want to pause the video and make sure that you can perform those mathematical calculations yourself. You can use a calculator if you'd like. I'm just teasing. These numbers are very, very easy to compute. All right. So there we have the price index. Okay. By the way, in the base year, the price index will always be 1. Now, let's compute the constant dollar GDP, or just easier to say, the real GDP. How do we do that? We simply take the nominal GDP and divide it by the price index. The nominal GDP divided by the price index. 4 divided by 1, of course, is, let me read this here. We deflate the nominal GDP by the degree which prices have risen. Or another way of reading this is we inflate the nominal GDP by the degree by which prices have fallen since the base year. And that's what this computation is doing. It's inflating the nominal GDP to the degree by which prices have fallen, or it deflates the nominal GDP by the degree by which prices have risen. By the way, this price index is often called the price deflator. Here's where it gets deflator from. The price deflator, but sometimes they have to inflate. So I'd rather go with price index rather than price deflator. So let's go ahead and compute the nominal GDP divided by the price index to get the real or constant dollar GDP. It's 4 divided by 1, which is 4, 6 divided by 1, which is 6, 24 divided by 2, which is 12, blah, blah, blah. Okay. Now let's compute the percentage change in the real or constant dollar GDP and to see how well it indicates the actual performance of the economy as measured by the percentage change in output. Well, the percentage change from 4 to 6 is 50%. The percentage change from 6 to 12 is 100, 12 to 18 to 50, yada, yada, yada. Check out these numbers. You see that the percentage change in real GDP is the very same as the percentage change in output. So the GDP there, the real GDP, is an accurate indicator of what's actually happening in the economy, whereas the nominal GDP is not. There's a percentage change in output. There's a percentage change in real GDP. You see that they are the same. So the real GDP is what's important, not the nominal GDP. Now, you're going to have to convert nominal GDP to real GDP on the test, okay? If you go to the course content lecture notes section, you will find a set of lecture notes there entitled Converting Nominal to Real GDP. Please read that brief essay. And then at the bottom, there is a link that will take you to a page that will provide you 2 practice sets where you can actually yourself convert nominal to real GDP. Now, this page where you're actually filling in numbers is JavaScript. That's the language that it was written in. And what you need to do, you enter the number in the box. You'll see what I mean. And then when you click out of the box, if nothing happens, then your answer was correct. But if you when you click out of the box and a dialog box will pop up if your answer is incorrect. It will show you what your answer is and what the correct computation was. You'll see when you get there. But please make full use of that. Get lots of practice in preparation for test number 3. So that wraps it up for the videos on the gross domestic product.